All right, this is Honors Algebra 2 Pre-Calc, and we are doing 3.3 in Algebra 2. This is the second video in the series, and we're going to talk about horizontal and vertical lines involving inequalities. So these graph just like any other linear equation, except with the vertical lines, like when you have x equals a number, or x is greater than a number, x is less than or equal to a number, whatever, there is no above or below the line, right? Instead, if x is greater than, you're looking for the larger x values, so you shade to the right. And if x is less than, you're looking for the smaller x values, so you shade to the left, right? So just here's a visual of the two of them, a vertical line, right? So this is x is greater than -2, right? You see the dotted line where x is -2, and then you would shade to the right because those the x values bigger than -2, right? Or if I gave you y is less than or equal to -1, here's the line where y equals -1, and we'd shade below. So another way to think about this, just worth putting on your radar, is if you kind of picture this, this is like taking a number line, right? Like a number line that you remember when we graphed solutions to inequalities before, right? And here's our x value at -2 and so on, right? So this would be an open circle, right? And then we would have shaded this way, right? Well, if you picture dragging this shape up and down, right? If you picture like physically taking this thing and, oh, I failed miserably, but you get the idea. Dragging this down, see how this carves out that shape that's shaded, right? So that's what that looks like, right? And it's not an accident. So the open circle is the same as the dotted line. It means don't include. And then the shading is all the regions above that, right? And then if you did the same thing, right, with if you did the same thing with this y, right, if you make we'll do it over here just for the sake of having some space, right? So if we do the same thing for the y, right, we want to close dot at -1 and then shade everything down here, right? So that's what we'd be looking at, is this closed dot and shade everything down there. So now if we'll see how this works, right? If we take this and drag it, you can see that that's the 2D version of the one-dimensional number line. The 2D version would be what we're seeing here on the graph. Okay, so that's sort of the gist of this. So in this particular section, what we're going to do is we're going to go over how to graph these vertical and horizontal lines as inequalities. And then once we've done that, we'll talk about compound inequalities, ones that have like x between two numbers, for instance, or y between two numbers. And then I'm going to do a quick little segue just to show you that you can actually shade above and below on your calculator, but it's really, really, really not worth it. Okay, so moving forward. So we're going to graph some inequalities, right? So again, I need to make some quick judgment calls, right? So the first thing I notice is that this is going to be dotted, right? Right? And then technically greater than would mean above, right? But because this is a vertical line, that means right? Because there is no above for a vertical line. So here's where x would be 3, right? And I'm going to make a little dotted line as best as I can at x equals 3, right? There's my dotted line, right? And then I'm going to shade, and again, I'm terrible at this, but you get the idea, right? And I'm going to shade values that are higher than that. So I'm going to shade over here, right? And you can check that you're right by picking any x value or any point over here and see that it does satisfy this. For instance, this point right here has an x coordinate of 7, which is clearly 7 is greater than 3, right? Here we have y is greater than -4, right? So again, I see that this is going to be a dotted line because it doesn't have an equal to, right? So it's dotted. And then I see that it's going to be shading above, and because it's a y line, right, it is going to be horizontal, and there will be an above. So I go to -4, right, and then my dotted line or my dashed line is supposed to be horizontal right here, despite my inability to draw things, right? And then I'm going to shade above that, so that's going to be this window up here, okay? And again, you don't have to shade every possible square. I get the gist that you're shading above the line. P5, right? So I see that this is x is less than a -1. So I say, okay, cool, that's dotted. And it's going to be below, right? But for x-only equations or x-only inequalities, that means left, right? Right, so for vertical lines, like this one will be, which you'll see at -1, this is going to be a vertical line. And again, sorry for my inability to manage to draw lines correctly, but you get the gist. Okay, so there's my vertical line, right? And I'm going to shade values below. Sorry for the stray mark. I'm going to shade values below, so that's going to mean over here. And sure enough, you can see that all those x values are x values that are less than -1. For y is less than 5, it's going to be dotted, and it's going to be below. So here's 5. Go ahead and make my big obnoxious dotted line, which is much easier than the tiny dotted line. I should keep that in mind. The dashes are much easier, and I'm shading below, so that's going to be down here. Okay? Cool. Moving forward. So now we have some equal to, right? So this is going to be x is less than or equal to 2. So the only difference here is that this is solid, right? And then the less than is still telling me to shade below, right? But remember, there isn't really a below here. It's going to be left because it's a vertical line. So I want a solid line at, was that 2 or -2? Sorry, I'm going to, okay, there you go. It was 2. All right, so I want a solid line at 2. Sorry, I thought I had the eraser, didn't. Okay, so there's my solid line as best as I can, solid vertical line where x is always 2, right? And then I'm going to shade below that, which is to the left, because again, if you're trying to picture the ladder thing, like there is no way to stand on this ladder. It's a vertical line, right? There is no above and below. Okay. For this one, again, I'm going to have solid and below, right? Those are the two qualities I'm looking for. For 5/4, that can be intimidating to some people, but it's just a 1.25, so it just means right around here-ish. And again, on a graph this small, nobody's going to be super picky if it's hard to tell if it was 1.25 or 1.3 or, you know, nobody's going to care. So there you go. And I'm shading below, so it's going to look like this. All right. P6, x is greater than or equal to 7/2, right? So this is going to be solid and above, but remember, for a vertical line, you can't really be above it, so you have to just be to the right, because it's a truly vertical line. Remember that 7/2 is the same as 3.5, so again, as best as I can, I'm going to try and draw this at 3.5. I will probably miss terribly, but I'm trying to split the difference between 3 and 4, and I'm shading above, so that's going to be the values to the right for x's, right? For this guy, it's also going to be solid and above. I'm going to go to -6. That's 4, 5, 6. Right? I'm going to make the best solid line I can, which is probably not awesome. And then shade above. Cool. All right. So for the next two, we're going to talk about compound inequalities. So if I give you a compound inequality, like -2 is less than x is less than or equal to 3, essentially what we're saying is that we want the numbers between -2 with a dotted line and 3 with a solid line. That's really what's happening. So what we're saying is that I go to -2 and I make a dotted line. And this is kind of a segue into what 3.4 is going to talk about. 3.4 is going to talk about systems of inequality, so that's this guy. And I'm going to have a solid line at 3. Again, as best as I can. We all get that I can't draw. Right? And I want the x values in between them. So it's going to be this window right here. And again, if you picture what this would look like on a number line, right? If we did this on a number line, it would have been an open circle, shaded in the middle, and a closed circle at 3, right? So if you picture that, if we drag it, that's exactly what this looks like. Like it looks like you're taking your one-dimensional number line and dragging it in 2 dimensions, where the dotted line is the open circle and the solid line is the closed circle, right? The same thing's going to be true here. My y is bigger than a 1, right? So I want y to be bigger than 1. Well, that's going to be a solid line at 1. So that's y equals 1. Right, there's my solid line. And that's solid because it's equal to, so solid, right? But smaller than 5, right? So that's going to be a dotted line at 5 because there's no equal to. So 2, 3, 4, 5, right? Dotted line at 5. And I want my y values to be the values in between, right? So it's going to look like this. But again, if you were to look at this on a number line, if we actually made a y number line, which we don't usually, we usually make x number lines, but if you made a y number line, here's your 0, right? You'd have a solid dot here and then shading and then an open dot here. And if you look at that, right, if you were to drag this, sorry, wrong thing. If you were to drag this, it would look like that if you drag it in 2 dimensions, okay? Cool, so you're going to try a P7 like this, and then we're going to do a quick segue into what it would look like to graph some of those linear equalities that we started this section with in a calculator and why it's not really worth it. So pause me if you don't want me to do this for you. All right, So it's going to be a dotted line because that would be an open circle at 4, right? So that's going to be right here, give or take. Again, nobody's expecting you to be perfect at graphing. This one's also going to be dotted at 7. Again, not a perfect graph. And this is saying you want all the x values between them. So you could pick any x, it doesn't matter, between them, right? For this one, I'm going to have a dotted line at -2. So y equals -2 is down here. I'm going to have a solid line up at 7. So there's 5, 6, 7. And I want to shade all the stuff in between. Okay? So that's the gist. So just to show you, if you wanted to see how to put some stuff in your calculator, so I'm going to go back to some of the examples that we did way, way earlier in this section, like in the first video. I'm just going to go back to an example that we did in the first video. Let's just go back to this one. Okay, so let's say that I wanted to graph this, and for some reason was stubbornly insistent on using my calculator. I can do it in my calculator, right? I can put x plus 2 in my calculator, and it'll graph a line. But if I want to make it shade things, I actually can go over to this symbol and hit enter. The first one will give me a really thick line. The next one will give me shade above, and the next one will give me shade below, which is what I want here. So now if I hit graph, it'll shade below for me. What it won't do, now your calculator does have the ability to graph a solid line or a dotted line. It doesn't have the ability to combine the dotted line with the shading. Also, I can't really figure out why this would help you a lot, because here's the thing, you still have to know that this means shade below. Like, you're not changing the actual symbol here, you're just saying I know this means shade below. So if you already knew it meant shade below, I'm not sure why it would help you to put the time in to make your calculator look like this. So I don't think it's particularly helpful, but you can in fact do that if you like stubbornly really wanted to. So anyway, there you go. That's our last video in 3.3.